Jay, so you head up the milling department here at Secol Engineering.
Yep.
You use your Haas machining centres. You're obviously familiar with the controls and the settings, and you obviously like them.
Yep.
This is a great example of parts that you're making. Can you just tell us, let's maybe start with this box here, what it is and how long it took you to make and the process.
Okay, this is an older version of the new box that you're going to see in a minute. It's a an electrical transmission unit. Unfortunately, we can't tell you more than that because it's a subcontract part. But we remove about 75 to 80% of the aluminium.
What grade of alley is it? Do you know?
6082 aluminium. When we first started doing it, we were just doing one on the machine. Now we batch the machine out to 9 off, which is around about a 12-hour cycle running overnight. A hell of a lot of material removed out of it. Lots of small cutters going in there and cleaning
So
it all up.
you just leave the machines running overnight?
Yep, just runs all overnight. We've had a lot of time to get the program running really well, running slowly when we need it to, running fast when we need it to.
And how do you run any kind of sister tooling or any monitoring, probing to make sure that when you come in the morning the parts are right, or are you just relying on the Haas machines?
We're just relying on the Haas machines. They're pretty reliable, to be honest with you. They run really well. A lot of it is in the setup. Obviously, you've got to use the right sort of tools to be able to trust that you are going to come in the morning, you're not going to have a sleepless night sort of thing. But yeah, it runs pretty well. I only have trouble when an operator's put the job in there the wrong way or something silly like that, to be honest with you.
Which must be a catastrophe. This, as a part, how much metal are you removing? 80% of a billet is gone, maybe?
Yeah, I would have said more than 80%, to be honest with you, because it comes in as a solid billet and then the wall thicknesses around it finish up at about 2 mil, so it's pretty thin and it's 54 mil deep. So I mean, if I wanted to work the maths out, it would be a hell of a lot of work, but yeah, it removes a hell of a lot of material out there pretty quick as well.
You cut and dry or with coolant?
No, we cut with coolant. So off the top of my head, the machine's running at 12,000 RPM and our feed rate is about 6,000 feed rough in the middle out of it with a 16 mil rapide cutter. So
and is this on the SS Haas machine?
Yeah, it's on the SS Haas machine, yes.
Have you seen a lot of improved performance on the SS machines compared to the previous ones in order to achieve what you achieved?
Yes, definitely. There's always been improvements in the Haas machines. Every time we get a new one, there's been new improvements in it. The new software is really good.
But the SS is specifically for high-speed machining, which this is perfect for, isn't it?
Yes, perfect for that.
Then we go on to this then. So what's the story here then, Jay? This looks a pretty intricate assembly. I know we're going to see it going together in a minute.
Yeah.
Same deal here, a lot of high-speed aluminium machining?
Yeah, a lot of high-speed aluminium as well. That's 6082 as well. Maybe the material removal isn't as much on this one because it's broken down into separate parts. But as you can see, there are 7 separate parts to the assembly. One of them is peak, which is a plastic part which does get moulded at the end.
And what are you machining this to? What have you got when it's all assembled? What's the tolerances?
Well, there are all different tolerances on it. Some parts are going to be open, but there are a lot of tight tolerances on heights, on bores, on positions. There's one hole on here which is a 22.5mm hole that's got a 0.1 tolerance on it, and the tolerance applies after plating, and it's nickel flashed. So we have to have good communication with the plating shop to be able to get that tolerance right at the end, so the thickness of their plating is correct to the bore size that we start with.
So the machines are achieving everything that you need them to achieve on both of this type
Yeah,
of part?
everything we've got here that we're showing you, it holds all the tolerances. As long as it's programmed properly and set properly, then yeah, it works fine.
Earlier on I was trying to find out what the comparison or what levels of stainless machining and other types of materials you were machining here. And I believe it's about a 30% stainless machining and then 30% aluminium. And what's the rest?
So we machine a lot of aluminium. We do stainless. We do 316, 304, 303. We do some special stainlesses every now and again, 316 LNs. We do a lot of oxygen-free copper machining. We do lots of plastic as well, your nylon 66, your PTFE, your PEEK, and mild steel. We machine anything, to be honest with you.
And you've got a lot of experience in the machines. You've obviously programmed them, set them, used them for many years, I'm assuming. If you had to point out a couple of things that you liked about the Haas machine tools, what would they be?
So I love the Haas machines. I've been working on them 10 years. Love the idea of the next generation control that's coming out. Sounds really good. But the communication between the operator and the machine's very easy. The programming's easy as well. It's all based on a nice format that's easy to learn. So I would have said that.
And the fact you can run overnight without having any issues is obviously important, because that's what makes you money.
Very important, yeah, very important. I mean, that's got a hell of a lot more for us in the last 5 years. Getting the programs to do a big batch, whether or not it's something we get better at as time goes on.
And you've got mini mills as well as machining centres, haven't you? Do you see a big difference between the mini mill and the bigger machines?
Yeah, I mean, I love the mini mill because it's such a small little machine. The envelope of the size of the machine is quite small, so you can get sometimes a product being machined quicker on a mini mill than you can on a big machine because it's not having so far to travel.
Brilliant. Let's see you put this together.